Okay, so welcome you all. I think we have a good audience here at this, really the first touch point for you with the UNAFCO INSAR training team. You probably have seen an email from Melissa that will have a few things coming up this week. So this today is a little introduction we'll give you to the OpenSAR Lab. The UNAFCO course will use the OpenSAR Lab as sort of its main training platform. And we just want to make sure that you know where to reach the OpenSAR Lab, how to sign up, and how to use it. And then later this week, we'll have a couple of course introduction sessions. We'll have one tomorrow at 5 to 6 p.m. Pacific time, and then another one on Thursday in the morning at 8 a.m. Pacific time. So you'll get reminders for all of those in your email. Melissa has been doing a fantastic job with getting those questions and those announcements out. And we also have some office hours that will happen on Wednesday and on Friday. So hopefully you'll have enough time and enough opportunity this week to contact us with your questions as you prepare for the training. And lastly, you also saw in an email from Melissa that there's a Slack channel that we're using to communicate. It's a good platform for students to communicate amongst each other. So please check into the Slack channel off and on. If you see any questions that you may have an answer for, chime in and help out right away. The instructors will also check in, and we have some TAs that will also look at the questions that may come up. So please take advantage of that Slack channel. The Slack workspace that we're having is going to be permanent. So it's potentially not only used for now, but later on, if you have any questions about ISCE, you could come back, post something in Town Square, maybe somebody from the audience or somebody from the instructors will see it and respond to your question. Today, I guess before we go into OpenSAR Lab, we have a few folks from the instructor team online. I see at least 3 or 4 here. Maybe Gareth, do you want to say a few words real quick before we do OpenSAR Lab?
Sure. Hi, I'm Gareth Running. I'm another of the organizing team for this course. I will be leading mostly the sessions on interpretation and modeling. One thing, I guess, to reemphasize on top of what Francis said is that these sessions are all optional. I saw questions on Slack already about, do we have to come to all of them? And the answer is no. Come to the ones that you are available for. We try to give a diversity of times so that people from different time zones will have the opportunity to come to one at a more convenient time for them. And other than that, welcome. I hope to see a lot more of you all in the next week and a bit, 2 weeks.
Yeah, and what you'll hear more from the instructors and who we are and where we sit in the actual kickoff meeting for the workshop, which is going to happen tomorrow. But if you are an instructor and you're online, maybe you can turn your camera on real quick and say a few words. I think I saw Eric Fielding on and Emre is on, I think. Yep, it's Eric. And Emre. So if you want to say a few words, you can. Oh, Simran is on too. So the folks that have the camera on, they are part of the instructor team. And you'll see their faces off and on throughout this week.
Yeah, I'm Eric Fielding. I'm going to be doing a lot of the INSAR class sessions with ISCE.
Hello, my name is Emre, and I will be taking part with the TAing office hours. So hopefully I'll be able to answer your questions while you're learning INSAR in this short course.
Yeah.
And welcome.
Sorry, Emery. Yeah, my name is Simran Sangha. I go by Sim for short, so that's fine. And I'll be working alongside Emery and Brett Bazenga behind the ARIA tools tutorial, getting a look at the ARIA standard product. So it's nice to virtually meet you all.
Hello. I'm Nilfar. I'm also part of the TA team, and I will be there for the office hours. And if you have questions, I'll be there to help you with that.
Excellent. Anybody else, instructors that are online?
Red was trying to.
I don't see him on right now.
He was trying to join.
Yeah, so before we get started, so, you know, as Gareth said earlier today, so there's some things that are very optional. So we have office hours there in the mornings and afternoons this over the next 2 weeks. Those are an offer to you if you have questions about either the code or the material that we talked about, installations, etc. You can ask us these questions during these office hours. We will be present at all of the office hours. We made sure that there's at least 1 or 2 of us always there, but it's not a requirement for you to attend those. It's an offer for you. The same with these all the sessions this week. We'll make those available to give you some intro information. Those are optional. We'll record all the sessions and put them on YouTube. For the main training section, we have what is like 3 or 4 hours a day. I think it's 3 hours, maybe, or 4. I forgot. We would like you to be on for those if you can, to have good presence during the actual lectures. And Gareth, it seemed like you wanted to unmute.
I say it was 4 hours a day.
4 hours a day, yes. It's going to be so fascinating that it's going to go by like 3 hours. Okay, so today, oh, there's a question in chat. Oh, there's Gareth. So today we'll talk briefly about OpenSAR Lab. The reason why we are using OpenSAR Lab for this course, and we would like you all for the course duration to try to do all of your exercises and all of the notebooks that we're going through on the OpenSAR Lab. The reason why we do that is because it provides a unified, identical lab environment for everybody, which has the advantage of, for a course like this, we have 150 people in this course. To make sure if first of all, ideally that things don't fail, we ideally won't run into issues when we execute the code. But if we do, at least the error we'll run into will be the same for everybody in the course. So it will help us debug if there are issues, debug things quicker. You know, in contrast, if everybody would install stuff locally, there would be no way that we could work with you with 150 people to try to make sure everybody's up and running. So we encourage you all to use OpenSAR Lab for the sake of this training. OpenSAR Lab, as you will see, has all the software packages that we need installed. So we'll have ARIA tools, MinPy, and of course ISCE and other tools that will be installed. All of these can be installed on your local machine. And we encourage you to do that at some point, but for the sake of this course, please use the platform. In terms of the platform, we'll provide you at the very end actually with a Docker container. So if you end up liking this sort of Jupyter Hub type, Jupyter Lab environment for doing your work, you'll get a Docker container that allows you to completely replicate the environment on your local machine. And alternatively, you can also install the individual software packages separately. Okay, let me dive in by showing you first a little bit of background about the OpenSAR Lab. And then once I'm done with that, we'll actually spin up OpenSAR Lab for everybody that already has an account. And I'm going to show you a notebook or two to just give you an idea of what these notebooks look like and how you interact with them. Okay, let's see here. So I'm going to just have a few slides in the beginning. See here, computer is being slow. Do you see my slide deck full screen now? Yep.
Yep. We can see it.
Okay, I'm trying to actually get it going. Okay, so the UNAFCO OpenSAR Lab environment is available for you at this URL that you see on this slide. Let me turn on my laser pointer here. So there's an https://unafco2022.asf.alaska.edu. Maybe I give you a sec. So most of you should have seen that already in an email or on Slack. If you haven't yet, please use this URL. Somebody may have put it in chat. Yep. So Gareth put it in chat and navigate to that. If you haven't yet created a login while I'm talking, you can create a login. If you already have a login, please feel free to spin up your machine and get your OpenSAR Lab environment started while I'm going through the slide deck. So OpenSAR Lab is a fully pre-installed and fully cloud-based processing environment. It's really built for working with SAR data, which often are very large in volume, and working with SAR-related software packages, which are not always the easiest to install and may have conflicting requirements for the Python and GDAL versions that you're using. So OpenSAR Lab provides you a setup that has everything installed in a way that the environment is completely consistent. It sits in the cloud so that you don't have to download data sets locally. You can reach OpenSAR Lab through any web browser from any internet-enabled device. So, if you use an iPad or a computer or a Mac or a Windows machine or a Linux machine, shouldn't matter for the accessibility to the platform. The OpenSAR Lab is a tool that was developed by the Alaska Satellite Facility. It sits in the Amazon Web Services cloud, and it sits right next to ASF's data archive, which makes access to the SAR data sets we'll be using this week quite straightforward. As I said, it's broadly installed. It's based, all the notebooks that we'll be using are Python based, so it's installed to support all of the notebooks that you'll use for this class. But if you have other notebooks from other resources, because it's installed with a fairly broad set of Python libraries, it may run most notebooks plug and play. The OpenSAR Lab, in addition to the software, it actually pulls all the notebooks and all the software requirements needed for this class. The software is pre-installed, and the notebooks are actually pulled from a GitHub repository. I'm going to show you a link later on to the Git repository if you wanted to clone that repository also yourself, or if you wanted to put it on your list on GitHub for long-term use. You'll see if you get to the OpenSAR Lab environment, you get to a launch screen that looks somewhat like this. Hopefully you achieve that. And then to get into it, you'll use the sign-in button to either create an account, or if you have one, to launch the OpenSAR Lab. Just a little bit of what the concept is of the OpenSAR Lab. The concept really is to connect you as a user, or as a scientist, or in this case, or as a student in a SAR training, to connect you, first of all, with all the software that you need to do your work, but also with all the data sets that you may need to do your work. So the OpenSAR Lab environment sits between you and the archive. It has access to all of the InSAR data sets that we'll use this week from ARIA, from the Griffin campaign. It has access to all of the raw sensor data that you may want to work with through a connection with the ASF Vertex search archive. It also has access to a bunch of notebooks, so it's automatically pulling in a bunch of notebooks from a GitHub repository. You can, additionally, of course, clone additional repositories that you would want to work with. In the end, OpenSAR Lab is an auto-scaling cloud-based lab environment. So when you log into OpenSAR Lab and the machine spins up, so the entire lab environment scales with need. We have had this year courses with up to 800 seats. So it just spins up more and more computers if more people are use the environment. It uses tools like Docker and Kubernetes that you may have heard of if you are familiar with software development. And all the storage handling uses AWS EBS volumes. So when you launch your machine, you get a hard drive connected to the machine, which is a solid state type EBS volume in the Amazon Web Services Cloud. All the orchestration of spinning up the lab is done through Jupyter Hub. And every seat actually used to have a Jupyter Notebook setup. Now it's actually a Jupyter Lab setup and has all of these software tools installed. So here are just some instructions. You'll see those in the slide deck, and you'll also see that when you watch the video. This is the URL you go to. If you then click on the sign up or sign in button, you come to this type of interface where you can either enter your username and password, or if you don't have one yet, there's a sign up link. And if you follow that sign up link, you can create a username, create an email address. If you haven't signed up yet and you're doing it now, make sure that for email you use the email that you used also when you registered for this course. This is the easiest way of getting in. We have what's called whitelisted everybody in this course with their email address. So if you use the email address you used for the UNAFCO InSAR course, you'll be automatically let into the environment once you registered for it. You'll see once you signed up, you will receive an email in your inbox. Please look out for that email. It will have an activation code. So OpenSAR Lab, like most software tools these days, uses two-factor authentication. It's going to send you a little, I think it's a 6-digit number that you have to enter to verify that you're a real person and you're not some sort of a spam bot that tries to create a number of instances. If you're online, maybe you can give me a little heads up or a little thumbs up if you already successfully registered and signed up for OpenSAR Lab. I see 1, 2.
I registered, but it's taking really long to charge the server.
Yes, that's why I had you start up early. So that's a good point. When you start up the machine for the first time ever, or for the first time in a while, it spins up the machine from scratch. It's a little bit like starting your Windows machine or starting your Linux machine. It creates the machine, it spins it up, it installs all the software, pulls all the things. So the very first time it takes a little bit longer. And also when you come back after being away for a while, it also takes a little bit longer. So that's part of the reason why I had you start this a little bit early. But it shouldn't take more than like maybe 3 or 4 minutes.
Okay, thank you.
Okay. Let's see. Okay, so once you are actually spun up, and some of you may be at this stage now, you'll see that there's sort of one screen between you and the final OpenSAR Lab still. And that has server options. It seems a bit, not potentially very useful screen for this particular training because we have one server option only. So there's not much you have to do. You already selected your server option. You just have to click start. But you can imagine that in theory, there may be several profiles. Basically, each of these server options tells AWS what kind of machine to spin up, how much hard drive space how much hard drive space you need, how much memory you need, how many CPUs you want, and so on. And so we have a default server option for this course, but if in theory you could imagine that there are more than one, and it may be that 1 or 2 of you during this training run out of storage for some reason, and we might spin up a second server option sometime as the course goes along. But for now, just once you're there, just click start to enter the OpenSAR Lab. And once you have done this, you'll see a screen similar to this. Maybe again, looking for thumbs up. I see one thumbs up. If you've gotten to something that looks like what you see on the screen. And if you're still booting up, no worries. Just making sure that everybody roughly sees what. Yep, I see.
Yeah, the first time it can take up to 10 minutes to start your server.
Yes, the very first time it takes a little bit longer. So don't worry if it takes a little bit of time. But I see a lot of you see something similar with like this. This is what's called a Jupyter Lab environment. Have you guys seen this before? Let's see, let's do one more thumbs up for whether or not you're familiar with Jupyter. I see there are a number that are familiar. Excellent. So you're not brand new to this. This is great. But if that's new to you, also not a big deal. I think the environment takes not a very long time to get used to. So if you look at this interface, you see a few things. You see sort of the main pane of this interface, which in the end, once you sort of launch notebooks, it will show you your notebook here in this main pane. And if you look at the left-hand side, you have a little bit of a navigation pane. So this shows you where you are in the folder tree right now, and it shows you which folders are available on the machine. So here you are in your main home folder, and you have 3 subfolders that you can look at. Most of the information you need for this class is in this geosync subfolder. That one contains all of the notebooks that you will need for this training. So most of the notebooks you'll use, they are pre-cooked in this geosync folder, and you just will double click them. I'll show you this here in a little bit, and they'll open. You can run through those. But there's also options to create additional notebooks that you see over here. So let's see if I can do this here. Oh, so all of your notebooks are in the geosync folder. But if you wanted to create new notebooks, either this week or down the road, steal some code from the existing ones and build something new, for instance, you can create new notebooks in this main launcher window. You see there are 3 different ways of how you can launch a new notebook. The different little icons here really are only different by the kernel that they are running. I'll talk to this in a little bit. Every notebook will run in a specific environment, a specific Conda environment or a specific kernel. And this kernel will have different kinds of software packages pre-installed. We will be using for this class the UNAFCO kernel. Some of the notebooks that you will be working with will already point to the UNAFCO kernel. Other ones may not, and they may warn you that you're using the wrong kernel. But in the end, the UNAFCO kernel is the one that has ISCE pre-installed, MinPy pre-installed, Area Tools pre-installed, and all the Python libraries you need pre-installed. So you can launch new notebooks from scratch using these little links up here. You can also open things like a terminal. So if you're used to command line work, or if you want to check how much space you have left on your machine, etc., you can always use this terminal icon to create a little terminal window. So we'll exercise that briefly here in a little bit. If you wanted to work with data that you have on your local machine, maybe you have some additional Sentinel data that you want to upload, there's a little upload button up here in the interface that allows you to upload data sets from your local machine. That at times can be handy. We'll show you here in a little bit, there's a way of checking for which processes and which notebooks you have currently running. There's this little round symbol with a sort of a rectangle on the inside of it. If you click on that, it will show you all of the different notebooks that are currently running, and it'll give you an option to either close those out or leave those running if you choose to. So we'll exercise that briefly also. Lastly, once you're done with your work, I would encourage you first to shut down the notebooks that you don't necessarily need anymore. This will make the spin up of the OpenSAR Lab a bit faster when you come back. And then also, I encourage you to log out and shut down your server. The machine will actually automatically spin down after it's been inactive for a while. But if you want to be mindful of sort of the costs associated with the lab, please click on the shutdown and log out button and manually shut down your machine. When you shut down the machine, by the way, all of your work, everything you did, all the data you've downloaded, all of the notebooks you've changed, all of that work will be saved. All of your work is going to be zipped up and saved as a snapshot. And next time when you come in, it's going to be resurrected. So you won't lose work on the OpenSAR Lab when you shut down your machine. Everything remains and gets unpackaged again when you restart your server a little while later. I think I had one more. Yes. So if you need help, either because you are new to OpenSAR Lab or because you're new to notebooks overall, there is a link to the OpenSAR Lab docs here on top of the screen, which give you a lot of information on how to run notebooks, what are Markdown cells, what are code cells, how do you build a Conda environment, all of the things that you might want to do with an environment like this is captured there. If you run into questions that are not yet in the OpenSAR Lab docs, please feel free to email us or email the OpenSAR Lab team, and we'll make sure that we expand the docs to cover all the things, all the kinds of questions that you may run into. This slide is just a reminder that in the end, the content, the notebooks that we'll be running for this class next week is contained in the folder geosync, and then the subfolder UNAVGO 2022. So you see here there's the last year's folder and this year's folder, and please look at the UNAVGO 2022. And thanks, Gareth. He put that GitHub link also into chat. All of these notebooks actually automatically pulled when you launch your OpenSAR Lab instance. The environment is going to go out to GitHub. It's going to clone this repository. And one benefit also of you actually shutting down your machine when you're done is if one of us, let's pick Gareth as a placeholder, is going to update his notebook tonight, and is going to commit it back to the GitHub repository. Next time you spin up your machine, you always will make sure that you get the latest and greatest code and the latest and greatest notebooks from the repository. Yes, and Gary says his are not yet updated. So I've moved very quickly from a notebook skeptic to a notebook lover. I love Jupyter Notebooks and Jupyter Lab as a really nice way of giving you data recipes that are fully executable. So all the notebooks that you'll run through, they're sort of this mix of code and instructions. It allows us to walk you through the steps, how you would do certain things, for instance, with ISCE or with MinPy. But it also doesn't just give you a PDF, but it gives you embedded code cells to allow you to execute the code yourself, and to make sure that the result you are supposed to get is the result you're getting. So we have in OpenSAR Lab fully reproducible science. So if I run the code cells and you run the code cells on this platform, we'll get the exact identical results. I like notebooks because they're easily expandable. So the way I write new notebooks now is I steal from all the old ones. So it's a really nice way of repurposing code cells that you've seen in other notebooks, and then use those to build your own new little thing. This way, it's also a very vanilla entry to Python programming. So if you're new to Python, it allows you to see, Python in bit-sized pieces in action, and you hopefully learn Python a little bit more from going through individual processing steps. And you don't have to program from scratch. You can reuse the code that's already there. And the other thing that's good about the OpenSAR Lab notebook environment is because you do actual processing in the cloud. You don't need to have a very strong local machine. You don't even need to have a particularly strong local internet, because all of the heavy data processing is all done in the cloud and not in your local machine. That can be a benefit also. Can you reset the notebook if you want? So there's a question in chat. Yes, you can say, let's assume that you've screwed up a notebook. So you made some changes in the notebook that you just can't recover. You don't know where the errors are, but suddenly your notebook doesn't work anymore. I'm actually going to show you this in a little bit. One easy way, if you have a canned notebook that you for some reason screwed up, you can just delete the notebook on OpenSAR Lab, then shut down your OpenSAR Lab machine and restart it. And it's going to pull a pristine original copy of that notebook from GitHub, and you can start from scratch. Does this answer your question, Joel? Okay, yep. Yeah, so just a few more words on notebooks and on this environment. So you have full access to all of the data processing capabilities without needing to install it locally. You have a lot of existing notebooks that you can reuse. So if you wanted to do, say, if you are working at a university, or if you want to do, train other people using SAR, please reuse these notebooks. Those are all meant to be reused and spread. So please feel free to repurpose these notebooks as much as possible. OpenSAR Lab is going to provide you with hopefully enough compute and storage so that you can do all of the work that you want to do. And you don't actually have to download the heavy data. So you don't have to download the SLCs, which are large in volume and potentially many. If you want to do time series analysis, you may have hundreds or of interferograms. You don't have to download them locally, which gives you a much faster progress from start to sort of your science result. And then you only would download potentially the science product that you created. And so the last one I want to say, it's an extensible platform. So you can add more, if you have your own OpenSAR Lab machine, you can add additional notebooks that are yours. You can share and pull in other notebook repositories from GitHub. And you can, if you collaborate with other people, if you're using the same platform, you can make sure that you can easily share those notebooks because they are all based on similar code requirements. So also for collaboration, a platform like this can be quite useful. I see another question. Can we process any InSAR data and time series InSAR data over the world with the scripts using separate SAR data sets for different times? The answer to this question is yes. Is that true? Did we fix all of the ICE stuff is fixed, right?
Yes.
Yeah. There was a small issue with the downloading DEMs last week, but I think that was corrected. So yes, we'll be showing you, we'll have, if you're interested in MinPy, which a lot of you might be, we'll have a nice little notebook session on how to use MinPy, and you can then use that same notebook. And I think somebody will actually encourage you to do that, to either create individual interferograms for different earthquakes than the one that we use in a lab, or use different data stacks for different areas with MinPy. And I see Eric is unmuted.
Yeah, the DEM download issue is fixed in the sense that it now correctly connects to the LAN processes DAC server to download the SRTM data, but those servers still have some capacity problems at times. So it's a little hit or miss as to whether the download works or not, or it could take a while. So that's an ongoing problem.
Yeah, so we are using the Sentinel data sets from the LP DAC, from the NASA LAM processes DAC. Those are the ones that are pulled automatically by ICE, and that step can take a little bit when they are maxed out in their capabilities. But I think if you want to run your own data sets, in all likelihood, because you're all probably in different time zones, is that you may not do that all at the same time. So hopefully we'll be okay in terms of delays, and you'll get the work done that you want to get done. So with that, I want to switch over to the OpenSAR Lab. So if you have your thing open, please go there. If you haven't signed up yet, please use the opportunity to sign up. And I'm gonna stop my, if I can, I'm gonna stop my PowerPoint and switch over to OpenSAR Lab myself. Let's see here. And what am I sharing now? Still PowerPoint? Share my screen.
Yes. Oh, you had just PowerPoint.
Okay.
There you go.
So now I'm live on OpenSAR Lab. Let me zoom in here a little bit so that you can see it all. Maybe not. Usually that works. It doesn't work this time. Okay. So hopefully you can see that all fine. You see that you know, when you come in for the first time, you'll end up in your home directory, and you see that in your home directory you have 3 different folders that have content. You have a lesson found. I actually don't know if that has content. It doesn't currently. We have the geosync folder, which is the one that we mostly use. We have one that's called Conda environments. We may get back to that at the end of the session if there's a question about it. I see there's a question in chat. No, there's a thumbs up. So I encourage you all to go double click into that geosync folder. When you do that, you see that there's 2 different UNAVGO subfolders. So the 2021 obviously is the course content for last year, and we will be using the UNAVGO 2022 repository for this course this year. You also see here when the content was last modified. So in this case, because you haven't modified that yourself yet, it basically tells you when GitHub was last updated. So there's a content that was pushed to GitHub within the last 24 hours. So if you double click on that, and so now you are in the UNAVGO 2022 folder directory. So this is all content for this class. Let's see if we can unriddle a little bit what all these titles mean. The way this GitHub repository is organized is you know, you see here 0.0, 0.1. The first number is the day of the training, and the second number is the module of that day. So all the modules that are starting with 0, these are sort of things, sort of pre-event kinds of things or content that might be relevant before the course actually starts. So some of this relates to trainings that you have to do or should do, or pre-course materials that you should look at according to the syllabus. And others is just content, you know, about the training overall. You see, for instance, there's 0.3 accessing and working with OpenSAR Lab. If you were to click on that, it's currently empty. Once we finish the session, it will be filled with the slide deck that I showed you today, and potentially a link to the recording on the YouTube channel. So everything with 0 is pre-event stuff, and then 1 is all the materials for day 1, 2 for day 2, etc. So hopefully that makes somewhat sense. So as we go through the training starting next week, you can slowly hop from one element to the next. I may also tell you, if I sort of click on 1.2, for instance, that what's contained in these folders is not just notebooks that we might run, but also potential additional materials that will show. For instance, for this section 1.2, we'll have some PowerPoint slides that I think Gareth is going to go through on Monday. And we have PDF and PowerPoint versions for those. And there's a notebook that will also exercise. So all of that stuff is in there, including a README that describes more about the course. One little tip. So I showed you earlier today that there is a little icon that you can use to upload data to OpenSAR Lab. So if you just try and click this, for instance, it will just open up a browser and allow you to, upload stuff from your browser to OpenSAR Lab. But you can also manually, if you wanted to download files from OpenSAR Lab, for instance, if you wanted to download this PowerPoint file, you can just right-click the file and download, and it's going to download it to your local machine. So there's no separate interface button, but a right-click and download allows you to pull stuff. And also, if you click on File, I'm assuming there's also a download option. It should. There is download, but I don't know how to use it. So I think the easiest is to do right-click. Maybe while we are here, I encourage you to also go into that folder, and I'm going to show you what a notebook looks like real quick using this folder. So if you go to 1.2 geophysical modeling, you see that there is, I showed you also, there's the PowerPoint file and a PDF of the slide decks, and then there's a Jupyter notebook. Notebooks are identifiable in two ways. One of them, there's a little symbol that looks like a bookmark on the left-hand side. And you also see an extension, and notebooks have an extension of IPYNB, which stems from the original name of it, which was IPython notebook. So these IPYNBs are the notebooks that will run in this course. So please double-click this notebook. And did you all succeed in opening up the notebook? You should see something similar to what you see on the screen. See a few thumbs up. Excellent. So again, if you've already used notebooks before, this may be not very new to you, but I want to show you briefly, how a notebook, what a notebook is composed of. Let me actually zoom out here for a second to show you more than one cell in this notebook. So I'm going to go to 100%. So don't worry that you can't read this for now. I'm just going to show you what the different pieces of the notebook are. You should see that if you click on a part of this notebook, you get sort of a little frame. You get this blue line on the side, and sort of you see that this notebook splits up into different pieces. In the end, what a notebook is, it is a sequence of individual cells. So you have a cell here, and then a next cell and a next cell. So these are individual cells that make up a notebook. And these individual cells may do different things. You have certain cells, like this one on top, that mostly contains texts and graphics and maybe equations. These cells are called so-called Markdown cells. You can see that. Let me zoom in again for your convenience. If you look at the interface, you see on top here a little drop-down thing that says Markdown. So this identifies what type of cell you're looking at. So this cell is a so-called Markdown cell. And that is in contrast to other cells, which may be code cells. So in this course, we are using two types of cells, either Markdown to render text and render graphics that explain certain processing steps, or we'll use the second type of cell, which are code cells. You see here that this is a code cell, and the code cells contain executable code. In the case of OpenSAR Lab, all of the code cells are written in Python. So all the kernels that we are currently using on OpenSAR Lab are Python kernels. This is not a thing that's fixed for Jupyter Hub environments. So Jupyter can use a variety of different kernels. If you are into R, you can use an R kernel. There are C and C++ kernels. Might even be a Fortran kernel. And there are MATLAB and Octave kernels. So there's a variety of different kernels that are supported in general by Jupyter Hub. But all of our work is in Python because it's a shareable, very open source shareable language that makes it easy for us to share code with everybody. You see that in order to execute this code, we have to actually let the notebook know what kind of kernel to use. We talked about kernels earlier. You see the kernel represented in the top right of this interface. You should see here that it says UNAFCO. So this is the UNAFCO kernel, which includes all of the Python libraries we use, but also make sure that it includes MinPy, ARIA tools, ISCE, and all the other software packages we use for this training. So this is one of 3 kernels that are pre-installed. The other one are simple Python kernels, and then UNAFCO has Python plus all of the other libraries we need to run this course successfully. So before we run a code cell, I want to go back to the Markdown cell one more time. If you highlight this Markdown cell and if you double click it, you should see something that looks a little bit like what you see here. And so once you double click it, it exposes the code that's behind the rendered Markdown cell. You'll see here that what the Markdown cell understands is, first of all, Markdown language. Markdown is a very simple text formatting convention. It allows you to do things like this. You can use little hashes to identify headings. So this is a heading 1. If you do use 2 hashes, this is a heading 2, and so on. And you can render this, and it's going to render it in different heading formats. And you can also use, regular text without the hash mark. It's just going to render it in some default regular text format. And so you see how, the different types of text get other formatting based on a Markdown language. So it understands Markdown, which has some simple conventions. If you're interested in Markdown, you can just Google for Markdown language, and this gives you there are many cheat sheets for simple things that you can do in Markdown. But in addition to that, it understands, for instance, HTML. You see there's lots of HTML code embedded here. It also understands HTML graphic embedding, and it also understands things like LaTeX. So if you are familiar with LaTeX for equation formatting, this is also something that Markdown cells understand. I'm going to show you actually one here in a little bit, a Markdown cell. What's nice about OpenSAR Lab is it has actually a text editor included. So you see here, all the red stuff is words that it thinks are wrong. None of these in this case are actually wrong. Handoff might want it to be separated, for instance. So, if you write your own little Markdown cell, there's a little bit of help to make sure that you avoid typos, which was actually something that was missing for a long time in Jupyter Hub, but is now available. To re-render the code cell, there's 2 ways. An easy way is you can click on this little, run button. So this is this sideways triangle. If you click that, it runs the code cell and re-renders it. There's also shortcuts. I actually don't know where the shortcuts went. There used to be a button, and I can track that down, that sort of highlighted all the keyboard shortcuts there are. But if you do Shift or Shift Enter, it also will rerun your code cell and execute your code cell. So Shift Enter is actually running the code cell and jumping to the next one. So that's another way of running the code cell. So next, this is a simple Python code cell. So again, if you click on that and you click the run button, it's going to execute that code cell. In this case, it just defines the URL in which your notebook is running and sort of prints out that URL. So it's a very simple thing that it's doing here. So you can feel free to run through some of these code cells, and look what they do. We'll explain sort of what the individual code cells are doing when we actually go through the training. But hopefully this gives you a little bit of an idea of how to the different cells that are there and how you walk through a notebook. I should say one more thing is notebooks are a series of cells, and in most cases, it is expected that you run all these individual cells in the order given. So you are expected in most cases to run code cells sequentially in order for the code to work properly. There are some exceptions here and there where you can actually go back and rerun cells out of order, but in most cases, the assumption is that you run cells in the order given. So in the course, should you run into issues with your code where you get error messages, it may be that you missed a code cell and you forgot to execute a code cell above. Does that make sense? So you pay attention to that, to not skip code cells, but to run them all in order. You're saying, I got a question, is there a reason why you wouldn't see this top graphic? You're not seeing this top graphic here? Gonzalo? You can also unmute yourself if you, okay.
Oh, thank you so much, Franz. Yes, I cannot see myself that image, so that's why my question. I don't know if it's
Okay,
something.
did you not see it right away, or was it there before and not there anymore?
No, I never, I've never seen it.
Oh,
When
okay.
I double click the notebook, it didn't appear. There's a small like window showing like just the word image. That's it, but I cannot see the.
Okay. Do you want to? You can maybe, if you want, either send me a screenshot, or if you want, you can also take over the screen briefly. Going to show me what you see?
Yeah, 1 second, please. I will do it.
I'll just stop sharing.
Okay, I will send a screenshot. So I see basically this. Can I just send that image from?
Oh, you can also, if you want, share your screen real quick. If you want to, you don't have to.
Okay, sure, I can do it. Yes, 1 second. Maybe that's easier. Just here. Okay, here it is.
Ah, okay. Can you double click? And it never did anything.
Here?
Yeah.
Just okay.
Interesting. So it should be.
I think I have a problem. Just that dash at the end of the line, delete that character and it should be running.
This
Yeah,
one?
yeah, mine was that. I think it's just because of the writing, how the code. Yeah, just
Okay.
remove that.
Okay.
Yeah,
Yeah, that
and
works.
do shift enter.
Shift enter.
Oh no. Or
No.
mine was, it's just because of the code. It's getting to the link to that image and just run it. You have to make some.
Oh yeah, and you found something else. If you see something like this where you have 3 dots, do you see that? How he has now 3 dots? This is when you see 3 dots, it means that you were hiding certain cells. This is actually a neat feature that allows you to sort of fold away certain code cells that you've already run, or stuff that you find distracting at this particular moment. You can always unhide them again by sort of double clicking on that cell. Maybe you can exercise that real quick a little further down where you see the 3 dots below. And if you click on those, it unfolds the cells again. So make sure that you don't forget code cells that might be hidden behind those 3 dots, and make sure that you run all of these code cells as well.
I reckon, France, you could modify your notebook to have the image stored locally rather than pulling from edX.
Yeah, I wonder why that is. I'll figure that out. Are you the only one? Do other people have issues with not seeing the graphic?
I had a problem myself. I actually moved it to the just run the code and
Yeah.
change that link and it worked.
Can you scroll down a little bit through your notebook? There are a few more graphics. Hopefully the other ones show up for you. Oh yeah, you're for some reason for you they don't show up. Do you have? I wonder if there's some sort of a. Scroll down further.
Okay. So maybe it's related with my browser. I don't know.
It could be, it might be that you have something blocked in your browser that is needed. So the only time that I've seen that is for somebody that
Can you-
really locks down the browser too much, but or not too much, but maybe a lot for this particular one. Scroll down a little further. There should be another graphic now. Nope.
There's another image here, but then it's
Right,
not
you
showing.
don't see any of them. Odd.
Hi, Franz. Sorry. Gonzalo, can you click on the link that's in that image and see if you actually someone also posted that on the chat, I guess. If you can access that image from your browser, just click on that link and let's see.
Let me see.
Yeah.
Okay.
We'll figure it out.
Mm,
So it brings up something else.
So that should be public.
No, copy paste the link itself in the browser, it will open it.
Okay, but this is
Yes,
the
this-
link is from a course, right? Okay.
Yes, the other one, just try running that markdowns again. I think it's a bug from just a browser, it will work.
Okay.
Yeah, I tried it a few times and it just,
And eventually it worked.
yes, mine is just,
Okay.
yeah, just open it and like put some space, yeah, just,
Yeah.
I don't know, mine was after a few runs, it worked,
Yeah.
Okay.
So see if you can,
not a problem.
if it can be fixed. If it continues to be a problem, then I'm gonna, and if it's mostly because I'm using material that I had posted on edX, all of this is public. I can just put those locally and see if that improves it. Thank you for letting me
Thank
know.
you so much. Thank you so much.
If you surrender the screen again, I'll go back.
Okay, sure.
Yeah, so there's a bunch of these notebooks that are on there that we'll walk through. So please feel free to look at some of those already for the pre-course content. Just demonstrating real quick how you can see which notebooks you've opened and run and which ones are active. I showed you this earlier today. There's this little round symbol with a rectangle in the middle. If you click on that, you see the tabs and the kernels that are currently running. So the kernel for this notebook that I just had open is still active. And so you can cancel that kernel by clicking the X. And then if you have, once you ran through the course a few times, you may have 10 or so different tabs open in your OpenSAR lab. It would show you all these tabs open here. Right now, you only have one tab open, but you can also use that to sort of organize your tabs and close some of the tabs that you may have lying around. Another thing I wanted to briefly show you is how to use the terminal. So you may be familiar with like command line work, and you may prefer command line work at times. So you can just click on this little terminal symbol to open a command line terminal, and you can do things, simple things like ls or ls minus al. You can use things like zip. If you wanted to zip content of certain folders to download, you can zip things up. I mean, you can see what's running on your machine. All of these things are available through a terminal. You can also delete things, of course, using terminal. Just be careful, as if you're familiar with the Linux environment, you can delete stuff by accident that you didn't want to delete. The benefit of OpenSAR Lab is if you shut down your machine and you restart, at least the stuff that the original state of OpenSAR Lab can always be easily recovered. Or maybe I can demonstrate that real quick. Sorry, if I go back to this notebook that I just had open. So let's assume that I, did something terrible to this notebook and I sort of accidentally screwed up the code, and I don't know how to recover anymore. Oh, first of all, if you make changes to this notebook, and you want to save your changes, there's a little save button to click, and it will save off the notebook. You saw that was a little star. Let me do this one more time. You see that there's a little thick round symbol here that indicates that there's changes in the notebook that haven't yet been saved, and you can save those by clicking on this button. The notebook does occasionally save every so and so many minutes automatically, but if you want to make sure that you save your content, you can click on the save button. But let's assume that I completely messed up this notebook, and I don't know how to recover from it anymore. So one thing you can do is you can close the notebook, and then you can delete it. So I'm just throwing this notebook away. And so now it's gone. In order to get to the original state of the notebook, you then, once you deleted it, you stop your server, basically shut down your machine. You wait for the machine to shut down. And once it's shut down, the red button goes away. It now says start your server. You can click on start the server. It's spinning up again. You see that it didn't go through the whole blue line bar that you saw at first. So it spins up very quickly because I just had it up. I can start the machine. No, never mind. But it should go much faster. I hope I'm not lying. You see that it still knows my machine enough. It hasn't removed it entirely, so it starts up fairly fast. You also see what it's doing. What the different steps are. You can open that event log and it tells you a bit more. So now my lab is spinning up again. You'll see, in contrast to the initial time when you logged in, you actually don't necessarily end up in your home folder. You end up in whatever folder you left off. First of all, that's important to note. And you see now that that notebook is back. And if I double click that notebook, this stuff that I added in, I added in this print test. That stuff is gone now. So I recovered the original notebook content with the original pristine code. And it allows you basically to start from scratch if you did something bad and you ruined the notebook. That's an easy way of recovering from where you were. Okay, let's see what else could we. The OpenSAR Lab docs I wanted to show you. So this is a nice thing that the OpenSAR Lab team developed over the recent year. You see that there's this link to the documentation for OpenSAR Lab. Oh, you also see that sometimes when Jupyter releases new content, it does sometimes load some additional packages in the background, and it tells you that when it does that. But let's go to the docs real quick. So when you click on docs, it spins up a separate browser window, browser tab. And it provides you some information on the number of things that you might be interested in. It gives you a very small introduction to notebooks. It talks about the things that we talked about earlier, such as Markdown cells and code cells. So it gives you a little bit of an intro to how to use them. It actually uses that same notebook. That's funny. And that graphic that you didn't see. So this is what one of the graphics would look like. It talks about code cells, how code cells are composed, how to select cells, how to run cells, and all of these kind of things. So that's some useful content if you get started with notebooks. There's a little welcome screen, and then there's all these different topics that you might be interested in. Let's see, Git in OpenSAR Labs. It tells you a little bit of the Git puller that automatically pulls content from GitHub libraries. So this Git puller runs every time you are shutting down and restarting your machine. It always pulls the latest and greatest code into the OpenSAR Lab environment. Let's see, what else might you be interested in here? OpenSAR Lab kernels. It tells you a little bit, why are we operating based on kernels? And it tells you a little bit about how to shut down, blah, blah, blah. Hopefully it tells you about changing kernels. So If you run in this course into an issue where the notebook expected a kernel, but you are running a different one, it shows you here how you can change the kernel. You can do that by either by clicking on kernel and then change kernel. You can also do it by just clicking on the name of the kernel on the right-hand side and changing it there. And it also may tell you how to build an environment. So if you are more advanced and you want to create and build additional Conda environments, it shows you this on this side too. So please feel free to browse through that page. There's a little troubleshooting guide. Why did your kernel die, for instance, all of these different things that people run into. Please look through that to get a little bit of an idea of how OpenStar Lab works and the kinds of issues that you might run into. I see there's some chat notes. There's a question, would you please show again, how did you get there? Oh, to the OpenSAR Lab docs? Fatime, was that the question about? Yes. Yeah. So, you can click. Do you see this link on the top right on the screen where it says OpenSAR Lab docs? So that's how you get to the documentation, or you can use the direct link that Emery put in chat. Let's see. Are there other questions that you think you have now about how to use the platform? As I mentioned earlier, we will give you at the end of the training, we'll give you a Docker container that you can use to install the OpenSAR Lab the way you see it here on your local machine with all the software pre-installed, with ISCE, with MinPy and ARIA tools and all of these things installed locally. So that can be useful down the road. How do I open the launcher tab again? That's a good question. So let's assume that you closed your launcher. Let's see, how do I close the launcher? If I want to, I can close the launcher. It actually doesn't let me. Okay, let me you have to have at least one browser open. So let's say I closed my launcher like this. And you want to get that launcher back. So the thing that lets you launch a terminal or a new notebook, etc. You can recreate the launcher by clicking on this plus symbol. So if you click on this plus, it's going to reopen the launcher tab. Oliver, did you manage to do that? Excellent. Do folks have other questions? If that is not the case, then let me stop sharing my screen. So please feel free to play around with OpenSAR Lab, look into different notebooks as you have time this week, and especially if you go through the pre-course assignments, all the notebooks for that are on the platform. If you have questions, let us know either on Slack or send us an email. Easiest, I think, is to go and do it on Slack, because you have 150 people, including the course attendants, that may be able to help you quickly. In the meantime, tomorrow at 4 p.m., is that true? 4 p.m. Pacific? Check real quick. Yes. No, at 5 p.m. Pacific. 5 p.m. Pacific time tomorrow, we will have a first kickoff for the training week. So we'll have one tomorrow at 5 p.m. Pacific, and then we have a second one on Thursday at 8 a.m. Pacific time. So depending on where you sit in the time zone, you may prefer one or the other. You certainly don't have to go to both of them unless you really want to. But try to see that you're available for one of those two. Did everybody get Melissa's great email with the documents that has links to all of the Zooms for all of these pre-event sessions? Yeah, so when Melissa sends out stuff and has attachments, please bookmark those. Melissa is great at making sure that everybody's informed. We'll send out reminders before the event actually happens. And again, if you can't find it, if you know there's an event, but you can't find the Zoom, ask on Slack, and I'm sure somebody is going to be quickly providing you that input. And if there are no more questions, then I thank you for showing up today. I think we're all excited to go through this training with you over the next 2 weeks. And Gareth, do you have anything else?
No, I'm excited too.
Yep. Then thanks for showing up, and we may see each other tomorrow.